right, calculus. Welcome back here to another video. This one is like a certain question in your homework set, your first homework sets, which I believe is due Friday, 8/28. You might be like, Friday? We won't be here on a Friday. How do I submit that? Guys, will be told you'll be scanning things with your phone or your Chromebook and emailing them to me. So I don't know if we exactly address this question in your notes, so I do want to go over it. All right, so find any discontinuous points of the function and label them as a VA, which is a vertical asymptote, or a removable discontinuity. We call that a hole in Honors Algebra 2, and I told you we would give it its more proper name in calculus, and that's what we're going to do. So first thing here is we want to factor. Let's move you down a little. So we have f of x is equal to x minus 6, x plus 6. I want to see an absolute ton of work on your homework. Factor the top and bottom. A discontinuous point is when the denominator is 0. That's where you find one, that is. Okay? So set the denominator equal to 0. X plus 6 equals 0. X plus 2 equals 0. That's good enough for me. I have x equals negative 6. That's some kind of discontinuous point. And I have x equals negative 2. That's another type. Now, I want you to label them. Notice that the x plus 6's canceled with each other. So basically, I removed it away. We call that a hole. Holes got covered up, remember, in Algebra 2. So this is the removable. Spell that out. And then you can write discontinuity like that. All right, that is a removable discontinuity. Can you see that? Great. Anyway, remember, you can never get rid of an asymptote, okay? So that vertical asymptote did not get canceled. It remains. That is how it is a VA, okay? Draw a little arrow. That's the work you show on that type of question. If it cancels, it is a removable discontinuity. If it does not cancel, it is a vertical asymptote. All right. Next page here. Let's take a look at BIM. Got a lot going on in a very short space. Okay, anyway, there's nothing to cancel in B, so I simply set the denominator equal to 0. So 3 equals 4x. 4x is, or x is 3/4. There's nothing to cancel, so that is a vertical asymptote. Vertical asymptote. All right, makes the function there undefined at x equals 3/4. Then on C, x squared plus 9, folks, is not x plus 3, x minus 3. It is also not x plus 3 times x plus 3 because you're missing the 6x in between. Did you guys see any of that? There you go. Hopefully you heard me. But it's not x plus 3, x minus 3, and it's not x plus 3 times x plus 3. What it is, folks, the sucker does not factor. So, okay, I'll set it equal to 0, and I'll get negative 9 is equal to x squared, and you should know when I take the square root of a negative, get I, plus or minus 3i. But we don't graph 3i there on your xy coordinate plane, so this actually has no vertical asymptote. It has no hole, nothing canceled. So it has no discontinuous points. All right, nothing will make that function undefined. So we would put no discontinuous points. And let's take a look at this last one. Boop, boop, boop. Is that x squared minus 20, or x squared minus x minus 20, x squared minus 8x plus 15, x squared minus x minus 20, x squared minus 8x plus 15. Try to keep that brain moving. All right, there we go. Let's take this down to Factor Town. How much of this board will it capture? here with my trusty, not dusty yet, trusty tripod. All right, that's how the numerator factors. And the denominator would be x minus 5, x minus 3. Just like in A, we can see that some things are going to cancel. X minus 5s will cancel. Let's set those equal to 0 first. X equals 5 is something, and x equals 3 is another thing. You guys can see those both. They canceled. We drew the arrows in honors algebra 2. This is a removable, again, it's not a whole. We removed it, is a removable discontinuity. All right. This did not get canceled. This is a vertical asymptote. Might be wondering what that x plus 4 represents. Well, if I set it equal to 0, I do get x equals negative 4. And when the numerator is 0, that is your x-intercept. So the x-intercept is x equals negative 4. You have a removable discontinuity, x equals 5. The vertical asymptote is x equals 3. And to figure out the y-intercept, again, x equals negative 4 is the x-intercept. To figure out the y-intercept, low battery, let x equal 0, negative 20 over 15. So what is that, negative 4/3? Y equals negative 4/3 is the y-intercept. That's how you get the intercepts from a rational function. All right, folks. That will be good for you. And then after week 1, or Monday of week 2, Monday and Tuesday week 2, you'll be able to do that first homework sets. This is Yak Math Videos signing out.